All right. Let's check the, there we go. All right. Welcome to Lecture 12, although it's not really a lecture, it's an exam review. Real quick on homework, I was checking the homeworks, and some of them have been graded, but not all of them on homework 2.6 and 2.7. So I think they're about TAs are about halfway done with each of 2.6 and 2.7. So the 2.6 solution is posted. The 2.7 solution, I'm going to post that later today. I did have a question about that problem, and I'll talk about that here in a bit. But today's goal is to go through the material on the exam. Now, I always want to make sure that everybody is aware of this. This is how I compute the grade in this course. So attendance is worth 10%, homework is worth 30%, and then each of the 4 exams are worth 15% apiece. What I did last year is I posted a friend of mine from grad school, his name is Scott Morgan. He would play what he called the at-home game. So like when he got to when we got time to near the end of the semester, what he would do is he would compute his grade, and then he would back calculate what he would need to get on the final to get an A, B, C, whatever. He called that playing the at-home game. So what I did near the end of the semester is on Teams, I posted a spreadsheet called the at-home game. To where you could do is you could plug in your attendance grade, your homework grade, and each of the 3 exams and figure out what you need to get on the final to get such and such grade and whatnot. So I figured I'd do that this semester as well. So obviously it doesn't matter now, but because we're nowhere near done to the end, or near the end, but that way you have an idea. Homework 3.1 is due due Friday, so 4 days from now. It's a very short assignment that follows the pre-recorded lecture I posted. I know that pre-recorded lecture was kind of mathy, but in the end, the 2 processes by which you compute a cross product are very straightforward. So with that, I'm going to stop talking about announcements and get into the exam, because I know that's what you all are here to learn about. So I've split my review slides into 2 sections. The first section, I'm talking about the logistics, and then I'll talk about what's on the exam. So first off, let's talk about the schedule. So we're doing the exam on Blackboard, and so what I mean by that is it's going to be a timed quiz on Blackboard that opens up, and instead of opening it up at 1 p.m., I decided to open it up at 12:58. I wanted to open it up a couple minutes before 1. So that in case we have any crazy technical issues and whatnot, that we can sort of work them out, and you all have a little bit of time. And instead of closing it right at 1:50, I'll close it at 1:55. So that way you all have a little bit of time. Fortunately, I don't think this room is used at 2 p.m., so I don't see us needing needing to rush out of here. The exam is designed to be 50 minutes long, but I'm giving a little bit of a buffer before and after. Now, one of the things to note, I'm conducting the exam via Blackboard. Okay, so what that means is that the way this room is set up, you all are probably going to need to move around a little bit, because what I'm hoping is that we have enough room in this classroom so that where everybody can have a couple chairs to themselves. And the idea is that, you can set your laptop on one chair and set your notebook on another, and you can be doing the problems without your laptop getting in the way, because I can imagine that would be kind of clunky. But we got more than enough space in here for folks to do that. So be prepared to spread out a little bit on Wednesday. What I'm going to do at the beginning is I'm going to give everybody some, a set of scratch paper and whatnot to where you can do your computation. So you all will be given that at the beginning. So all you need to do is basically just hit submit on the quiz in Blackboard and turn that scratch work in after the exam, and you're done. I'll have just like a box up here that you can turn those in. So first thing I would mention is show as much work as you can. If I give you a problem and you just say the answer's 2 and you don't show any work and that problem's wrong, there's not much I can do in terms of partial credit, right, if you don't show me anything. So show me as much work as possible. I'm a partial credit guy. I will give you partial credit if I have something to go off of. If I don't have anything to go off of, it's kind of difficult. But yeah, But yeah, I am conducting the quiz, the exam via Blackboard, but you'll turn in the scratch work as well. When we did this virtually last year, I had two things that opened up on Blackboard. There was a timed quiz, and then there was like a PDF submission page to where you can upload your work after. But given that we're all in person, I can have you all just turn that in physically. I don't think that's a big deal. All right, let's talk about the operation. So the quiz on Blackboard will be a forced completion quiz. So once you start it, you have to do it all in one sitting. If you accidentally hit submit on something like, oh no, what do I do? Just let me know. We can revise that. But the idea is that once you start the quiz, you have to complete it in one sitting. So if you have any technical issues and whatnot, let me know. It is a timed quiz, and so it'll save and auto-submit after 60 minutes. That's for your benefit, not to punish you. The idea is that if for some reason you forget to actually hit submit, that it'll save your answers for you. So that's for your benefit. That's not to be a pressure. I do have this test set up to where all the questions will appear all at once, as opposed to like one at a time. So like instead of like answering question one and then moving on to question two, they'll all show up at once. And so that way you can go back and review your responses before submitting. That again is for your benefit, not to be a hindrance. As for approved materials, look, I'm an easy guy to get along with. So I have no problem if you use your book and your notes. I mean, you're doing the exam on Blackboard, and so the exam will be you'll have your laptop with you, so you can use open book, open notes. I have no problem with that. You can use any resource that's on Blackboard, lecture notes, recordings. The homework solutions will be available. I don't have a problem with that. I really don't. The one thing I do have a problem with is you giving or receiving aid from another individual. And so what that means is, each other, Chegg, all that, because that's, Chegg didn't just miracle itself onto the internet. Somebody, put that there. So, but I think that between all of the stuff that's available on Blackboard, I really don't think you'll need any other resource. Again, I'm an easygoing guy, so I think you'll be good there. The format, in terms of what will be on the exam, it will be 4 to 5 short answer conceptual questions. And when I say, I have a little bullet here, no more than 1 to 2 sentences. I have given exams before, and it is so funny to see students, I have a short answer problem that's worth 4 points, and I get Shakespearean sonnets as answers. It's like, what's the answer? The answer's 3. Just write 3. Move on, time management is important, okay? So if when it's a short answer question, it's a short answer question. And so some of my short answer conceptual questions might be sentences. I might give you a problem and just say, just tell me this one value, just short stuff. So 4 to 5 short answer conceptual questions and 2 to 3 what I would call real problems, okay? Do me a favor on Blackboard and type out an answer for every question, even the computational problems. It does help me a lot with grading. There's 60 people in here, and so if I can download all the responses, and just to make it simple, let's say the answer to problem 6 is 27. I can download all the responses, and if I see 27, correct, wrong, I can do that very, very quickly. You don't need to use that equation builder and whatnot inside Blackboard. You can just type it out. Just keep it simple. But please do me a favor and type out an answer for every question, because it makes the grading go by a lot faster. Don't just answer the question on your scratch work. That doesn't mean, please, show your work, and you can write the answer on your scratch work, but it makes it a lot easier if you type it out. That's the format, okay? Let's talk about the topics, and then I'll open it up. The topics. So what are we covering on this exam? This is it. This is what's on exam 1, the fundamentals and the statics of particles. So fundamentals. Make sure you understand classical motion and Newton's 3 laws. This is not physics 211. This is not calculus 1. I'm not having you derive, fourth order differential equations. I just want you to understand it. Make sure that you can compute the weight of an object, where weight equals mass times gravity. Make sure that you can convert units and perform dimensional analysis as appropriate, and be able to employ concepts in algebra and trig. As for statics of particles, make sure that you understand the properties of a vector. make sure that you can add vectors using the three components that we really discussed. And really, two of these components were kind of together. The graphical and the trig approaches were all kind of the same thing. But these two, and then addition by vector components. And then be able to apply equations of static equilibrium to 2D and 3D concurrent force systems. And also, in order to do that, you have to be able to solve 2x2 and 3x3 systems of equations. And so that's the stuff that we've been doing in the Casio and whatever your TI-84 or whatever calculator that you have with you. By the way, if you missed something, these slides are also on Blackboard right now, so I'm not keeping this from you. In terms of formulas, one of the other things I like to do on the exam review slides is I like to distill all the stuff that we've been talking about for the past few weeks into a series of slides. And so I've done that here. So on the next slide, so first off, these are our fundamental equations and concepts. So I've got here weight equals mass times gravity. Here's the gravity term for US units as well as SI units. I've got the base unit, so I've got, quantity length, or this is what we would use in SI and US units respectively, as well as the two sort of special ones like the Newton and the slug. They're sort of derived from everything else. I put trig all on one slide. This is trig. This is all you need for the exam, the trigonometric preliminaries. The basic definitions of the sine, cosine, and tangent functions. I've got the conversion between rectangular and polar coordinates, because that tends to pop up when we're doing resultants. And then the law of sines and the law of cosines. In terms of vectors, these are the basics of vectors. So I've got the unit vectors, ij, and then ijk right here. This is the graphical approach to adding vectors. The idea is the tip-to-tail fashion for doing it graphically or trigonometrically, and then recognizing that the order of operations doesn't matter. The p plus q is the same as q plus p. This is the graphical or the trigonometric approach. This is the addition by components, taking a vector, splitting it up into its x and y components, and then adding those coefficients together in order to determine a resultant. And then in terms of vector expressions in 2D and 3D, this is the 2D set of expressions and the 3D set of expressions, and the whole point was to convince you that they're actually not all that different. They're actually pretty similar. In order to add vectors by components, you're doing it the same way. In order to determine the magnitude of a vector, you're doing it the same way. It's just, another term in 3D. Equations of static equilibrium, pretty straightforward. The one thing that was maybe a little unique was orientation of vectors. I'd argue that it was actually a little easier how we did it in 3D than it was in 2D, because in 2D, we did cosine and sine respectively, whereas in 3D, we just did cosines and say all the angles are just from their respective axes. And that's it. That is the exam in a nutshell. That's the format. That's what we're going to talk about. That's what we're going to cover. Now, what I want to do now is sort of shut up and let you all ask questions. I did get some questions on Teams, and I want to go through them quickly. I had a few questions on Teams. I had one student send me an email, and so I posted that response to Teams as well. One student asked me via email if I would come up with a series of practice problems that, some extra practice, right? And so this is what I did, and there were two responses on Teams, so I wanted to make sure I was responding to both of those students. So the question on Teams was about determining 3D vectors, like doing the describing vectors in 3D. So what I did is I came up with 3 problems in the textbook, and I said, here are the problems, and then here are some intermediate answers, so that you can open the book, do the problems, and see if you're getting the same answers I'm getting. And I didn't just say, here's the problem and here's the answer. I tried to come up with the problem and some intermediate values so you can check your work as you're doing it, okay? And I did the same thing for not just 3D equilibrium, but 2D equilibrium, 2D resultants, 3D resultants. So I tried to combine those topics and come up with a list of problems that you could practice on your own if you'd like. You don't have to, but I'm of the opinion that if you followed along with what we did in the lectures and you follow it and you understand the homeworks and whatnot, you're going to be fine on the exams. But for those of you that want extra practice, that practice is available. I did have one question about going through some of the homework problems. One of the issues was I had a student wanted me to go through homework 2.7. I will go through a little bit of it, but I'm a little concerned about going through all of it because I know that there are still a few students that have yet to turn it in. And so if I start going through the solution, it puts me in a little bit of a pinch. But I don't mind to go through homework 2.2 because that student asked about that. Before we do that, though, I'm now going to shut up. Any questions about the format, topics, anything that I haven't covered? Floor is yours. And again, one thing I didn't mention at the beginning, these exam review sessions can go as short or as long as you all would prefer. I've had exam review sessions that took every bit of 50 minutes, and then I've had exam review sessions at this point where everybody's like, nah, Dr. Mike, we're good. Okay, Any questions? Because I am going to do that homework 2.2 review if nobody else has any other questions.
Could you run through like a couple examples of the pulley problems?
The pulley problems. Yeah. Okay, let's do that here in a bit. Okay, I'm gonna go through 2.2 and the pulley problems. So let me keep that in mind. I might do the pulley problems first because they're a little quicker. Any other questions? Any other questions about the format, about how that's going to work? Oh, I do have one thing to say about format. I've had, I think, one or two students mention that either that they have their laptop's messed up or they're worried about the battery charging or whatnot. If you're going to have a problem and you know that okay, my laptop's not going to work, you need to tell me in advance. Okay, I think I've had two students tell me that that's going to be a problem. That's okay. But if I show up and I'm ready for two students, I've got 20 students who can't access the exam, that's going to be a problem. So if you think you're going to have a problem with your laptop, let me know now. Send me an email, okay? And if you've already told me, send me an email anyways, just to remind me, so that I don't forget. Any questions? Is everybody okay with pulley problems and graphical vectors, or is there anything else that you really want me to cover? I can cover 3D too if you want. Y'all gotta let me know. Don't be shy. All right, let's do pulleys first. Okay, let's do pulleys first, and then we'll break out one of the 3D problems and go from there. Okay, so let me see. You remember what lecture that was? It was lecture statics of particles 5. I just remember that was the slide that had Obi-Wan, or right before Obi-Wan. There we go. Okay. All right, here we go. So let's start off with the pulley problems. Okay, so in terms of the pulley problems, the thing that you've got to recognize is so the first thing that I like to do is I like to look at the free body diagram of the pulley that's right next to the block. So let's make up a number. I think a lot of the problems that were in the book said that this block was 600 newtons? Is that what it said? Something like that? So this is 600. What'd I do? Did I do something? I didn't tell the joke, did I? Okay. All right. I missed something. Okay. So when it comes to the pulley problems, the first thing I like to do is I like to sort of look at the free body diagram associated with this pulley. And when you're looking at the free body diagram associated with this pulley, what I sort of want to focus on is this case and this case, because they're actually no different, okay? When you look at the free body diagram of this pulley right here and this pulley right here, it's still 600 newtons and then an upward force of T and T. And it's the same free body diagram for this one as it is for this one. Same story with that pulley. Pulley, up T, down 600 newtons. So T is 300 newtons for both of these cases. In fact, I mean, they're not any different. They're the same case, okay? What made them different, okay, there's this little pulley up here, but if I look at the free body diagram of this pulley right here, I've got a pulley, I've got down T, and I've got down T. All this is going to tell me is that whatever this reaction force, whatever this reaction force here is 2T. In other words, that's how much force is required to keep that bolted to the ceiling, but that doesn't affect how much tension is in the rope. Does that make sense?
So it's pretty much solely relying on the one closest to the weight?
Pretty much, yeah. Pretty much. And so that's what makes this one different right here, because if I look at the free body diagram of that pulley, I have 600 newtons, but then I've got 1, 2, 3 going up, right? So that's where we get T is 200 newtons. And so when we look at this one, this is all like one big pulley, which is why there's 1, 2, 3, 4 ropes. Same thing with this one here, and that one there. Not all that different. Does that make sense? Everybody okay with that? Okay. Now, let me do this graphical problem. I'm going to do, and to be clear, did you say homework 2.2, or were you saying homework 2.1? Because that was problem 2.2. Whoever posted that on Teams. Mr. Queen, I think it was.
I think I meant the actual homework.
Homework 2.2. Okay, all right. So let's look at that. All right, so
Yeah, it was homework 2.2.
okay, so all right, first off, I don't have the original problem image here, but let's see, if I remember correctly, this was a problem where there were 2 ropes trying to yank a box out of a chasm, something like that, right? So if I remember correctly, I think that problem was, it was something like here's a box, right? I had a little hook on it, and there was this and that, right? Yeah. Okay. And help me out with the data. So this was yanking like this was yanking like that. Okay. And we've got this and that. Okay. Now, this angle, what was this angle?
30.
30, and this is theta.
Yeah.
So 30, and this is theta, right? Okay. Now, the magnitudes. What's going on with the magnitudes? This is, do we know either of them?
Yeah, the one that's 30 is 425.
Say it again.
The one that, with that one is 425.
425 pounds.
Yeah. The other one just P.
Is just P. Okay, and the idea is to figure out what P and theta is such that the resultant is vertical. Yeah. Okay, all right. So what I'm going to do is I'm going to do a little, first off, let me just say there's a couple of ways of going about this, okay? So the first way of going about it is to dispense with all this graphical and trigonometric stuff and just do it algebraically. Just break it up into x and y components, okay? That is the first way of doing it. Because what I could do is I could take this vector and write it in IJ format, take this vector and write it in IJ format, right? And add it up. So think, let's do that, okay? Because I think that would mean a more equitable review of the material, because that way we're doing it all. So method 1. And I won't sidestep, because we'll do it the other way. Let's see. Actually, yeah. So see what I did there? So I'm writing that vector in IJ format. Would that be a fair description?
Yeah.
So negative, positive, magnitude times cosine and sine, right? And then this second vector, we'll call it F2. Would that be a fair assessment? Okay, so we have to add these up in such a way that the resultant is vertical. Is that what you said?
Yeah.
Okay, so if the resultant is vertical, if I add these two up, what do the sum of these two need to be? 0, right? So it would get a little algebraically messy, but what I can do is I can say, all right, let's sum forces in the x direction. And we're not setting this equal to 0 because it's not. We're just trying to add two vectors to determine the resultant. So this would be P cosine theta. Well, actually, hold on. I guess, yeah, that would be 0 because it's not because it's adhering to the principles of static equilibrium. It's just because the problem wanted the resultant to be vertical. So P cosine theta minus 425 cosine 30 equals 0, right? Now we can handle this a number of different ways, but what might be the easiest way is, I don't know, solve for P. So what we could do is we could say P cosine theta equals 425 cosine 30 degrees. What was that? Right? We could do that. Now, did it say what the magnitude of the resultant needed to be? I think there's another data point that I'm missing. What did it say in this problem? What did the magnitude need to be? Didn't it say something like 4? Anybody have this homework assignment on them? Let me see. I missed something. I feel like I'm missing some data here. Maybe I'm not. Oh, that's what I'm missing. That's what I'm missing. This is 500 pounds? Okay, that makes a lot more sense. I'm like, something's not right here because I'm missing something. Is that right?
I guess that, I don't know. That's probably where I missed it because I didn't have that wrote down in my diagram.
Okay, well that'll explain it. So, okay, now I was like, something's not right here because I'm missing some data. So now what I can do is go back to this and I can say, hold on. Let's go back to this vector description. So now this is 500 cosine theta plus 500 sine theta. Okay, now do I have this right? I feel like I was like, something isn't right here.
It also says that the resultant angle is vertical.
Yeah, now that I knew. And so that's where we were headed earlier, was that if the resultant is vertical, that means that these have to sum up to be 0. Does that make sense? Okay, so let me back up here to make sure that we're understanding what's going on here. So I have these two boxes that are this box is being yanked up by these two cables. Okay, Now, I know that this is 425 pounds at an angle of 30 degrees, and I know that this is 500 pounds, but I don't know what the angle of orientation is. So ultimately what I'm trying to do is I'm trying to find the angle of orientation, and I'm trying to find the resultant. Okay, so what I'm doing here is method one. I wrote these vectors in IJ notation. And the reason that I did that is because if I know that the resultant needs to be vertical, then I know that the summing these x components up has to be 0, right? Because if I have a vertical vector, that means that its x components are 0. So now I'm going to add these two up, and now that I know what p is, I can solve for theta. Now it's a little better. So 500 cosine theta minus 425 cosine 30 degrees is 0. Divide by 500. And so theta is cosine inverse of that. Now, what do we get when we plug and chug this? $42.6. Do I have a second on that? Okay. Now let me just check something to make sure I'm not crazy here. That was what we got for the answer in the problem. Okay? So don't worry, I'm going to do the triangle method here in a bit. But is everybody with me so far? Now, the problem stated that the resultant needs to be vertical. If the resultant is vertical, then the sum of the forces in the x direction equals 0. That doesn't mean that the sum of the forces in the y direction equals 0, because this isn't a problem where we're trying to maintain equilibrium. We're just trying to figure out what the resultant is. So therefore, what we can do for the resultant is we can say the resultant is just the sum of the forces in the y direction, which is 500 sine theta plus 425 sine 30 degrees. The thing is, we now know what theta is. Theta is 42.6 degrees. So what's the resultant now? So 500 times sine of this plus 425 times sine of that. Now that we know what theta is, what's the resultant?
550.9.
550.9. Do I have a second on that? So here's the angle. Here's the resultant. And if you go back to the calculations that I submitted in the solution, that's exactly what we got. Okay? So that's doing it another way. Okay? This is doing it using the IJ notation. Now again, that's me skirting doing the graphical approach. I'm going to do the graphical approach here in a bit. Okay? But before I do that, does that make sense as to how I did that? And again, the kicker is, because the reaction is vertical, the sum of the forces in the x direction equals 0. But the sum of the forces in the y direction aren't 0. The sum of the forces in the y direction is whatever the resultant is. Because here's the thing. The reason why the sum of the forces in the y direction isn't 0 is because this problem is not about the box sitting still. The problem's about the box moving, right? We're trying to lift the box. So that's why the sum of the forces in the y direction does not equal 0. Okay? Make sense? Everybody okay with that? Now, let's not cheat. Let's do it the way we were, intending. Let's do it the actual way. Okay? Okay, so here's the problem. Let's do it the graphical trigonometric approach. Okay, so the graphical trigonometric approach states that we stick these vectors on top of one another in a tip-to-tail fashion. And so what I'm going to do is I'm going to take that 500-pound vector, and I'm going to do this, graphically. I'm actually going to do this with you right here. Okay, and I know the scale won't work, but the idea, so watch this with me right here. So the idea is that I am actually taking this vector and I am moving it, over. Oh, I'm going to get this. I'm actually taking the vector and moving it up like that. So I'm actually taking it and moving it. So I'm actually going to move it like right here. That actually worked out pretty well. That's what I'm doing, okay? Now, when I do that, let me move this down. I'll just rewrite that. Now, when I do that, I get the following scenario, okay? And the idea is that the resultant looks like this. This is the resultant. And the idea is that the resultant is vertical. So if I flesh this out a little bit, here's this, and here's this. Now, I'm going to draw a little line here because I want to figure out these angles. Okay? Now help me out. What is this angle right here? What's this angle? 30, right? This is 30 degrees. And I got that from right here. So if this is 30 degrees, what's this angle? 30 degrees. And what's this angle? Well, we don't know that right now, but we will. Well, it's theta. It's theta. Now, if you're able to do that on the exam, you're going to be just fine. Now, this is 425. This is 500. Now what we got to do is figure out this resultant here. Okay. Now if this is 30, what's this angle? 60. Okay, see, we're already figuring stuff out, okay? So so 500 is to 60 as 425 maybe is to that. That's a way of doing it. We don't have to do it the way that we did it in the solution. There's more than one way of doing it. How about this? Let's try that. Let's see what happens. Exercise those trig muscles a little bit. Well, here, let's write it the other way. So sine 60 degrees is to 500 as sine of, what do we want to call this angle right here? Alpha. Let's call that alpha. Alpha is to 425. What's alpha? 73.6. Do I have a second on that? Everybody with me on that? Did I get that right? Nobody's saying anything. Okay.
I got 47, 402.
All right, hold on. Let's check. All right, what'd you get?
47, 402.
Who else got 47, 402? Okay, we got more people getting 47, 402.
Yeah, I think it's just where I tried to combine steps.
Okay, all right. So alpha is 47.40 degrees. All right. So help me out. Okay, I've got a bunch of angles inside this triangle. What do all those angles have to add up to be? 180. So 60 plus alpha plus 30 plus this theta needs to be 180 degrees. So 60 plus 30 plus 47.40 degrees plus theta is 180. What's theta? Anybody got an answer? Either that or I feel like we got a math error. 42.6. Now hold on. Help me out. Is that the same thing we got up here? Well, by golly gosh gee, look at that. Is this making sense? I don't want to just throw a bunch of numbers on the screen if nobody's getting it. And if you're not following something, let me know. Does this make sense? And so now I've got all the angles inside the triangle solved. Take your pick, whatever, law of sines, law of cosines, do whatever you want to solve for the hypotenuse, and you'll get 550.9. I actually think you should try and do that one on your own, okay? What do you think? Any questions? Now, in the interest of ensuring that I'm not revealing the solutions to homework 2.7 yet, how about we do this for 3D to sort of call it? Oh. Let's just do this. It seems to me that the hardest part about the third dimension is describing your vectors. Once you get that, it's kind of cakewalk, am I right? So let's do that. Let's do something. I have an old set of presentations here. Let's see. Here we go. Let's just use this one. Let's just use this. All right? It doesn't matter. Just a random problem. I think this might actually be one of the ones that I suggested on Teams, that let's use this as a means of describing some vectors. Okay? So let's pick one. AB, AC, AD. Tell me which one you want. AB, AC, or AD. I don't care. Pick one. AB. Okay. So, AB is a pile of junk times I plus a pile of junk times J plus a pile of junk times K. Okay? And what I'll do is let's just do them all. Because why not? Oh, don't you do that. All right. Okay. So let's start off with AB. Okay? So here's the cable that we're looking at. Okay? And we're following in both the x-axis, the y, and the z. Okay? So let's look at the x-axis. Okay? So here's A, here's B. So these are the dimensions that we're looking at. Now, A is directly over this hinge here at the bottom of the tower. So along this direction, how far is it from A to B? Along this direction only. Negative, here we go, negative 45, right? When you see this X right here, and this Z and this Y, that indicates the positive direction. So if I start right here, that's the positive X direction. From A to B, along this axis, we go backwards. Like here's A and here's B. So we're going negative, right? And along that axis, negative 45 feet. What about the Y? From A to B, from A to B, how far down do we go? And notice I'm using that term down. Negative 90. In fact, that's all these, right? They're all negative 90 because they're all going from the top of the tower to the bottom of the tower, and the tower's 90 foot tall. Now how about the Z dimension, or the Z axis? Somebody else. 30, positive or negative? Positive, exactly right. This is the positive Z-axis. From A to B, we're going forward. We're going in this direction along the Z-axis, and we're going 30. Now, somebody tell me AC. The whole thing, just AC. Somebody. Goodness, whoops. What? Somebody, what's AC? Yes.
30 feet I had plus negative 90 J hat plus 65 feet K hat.
That's exactly right. Positive 30 along the x-axis, positive 65 along the z-axis. That's exactly right. AD, somebody else.
20, negative 90, negative 60.
20, negative 90, negative 60. So let's see. Along the x-axis, positive 20, negative 90. Along the z, we're going in the opposite direction of positive z. This is positive z, this is negative z. From A to D, we go back, negative 60. That's exactly right. I mean, once you've got that, it's pretty rote at this point, right? Get your magnitudes, divide by the magnitude to get the unit vector, multiply by the magnitude, boom, you got your force vectors. 3 equations, 3 unknowns, plug it into your solver. There you go. All right, let me stop for a second. Everybody's packing up. I know they see that 149. Any last minute questions? Okay. Between what we've done in here, your homeworks, the homework solutions that are posted, the problems that I've got posted on the teams, you should have more than enough material to study to get ready for the exam. Bring your laptops on Wednesday. If you are going to have a problem with that, please let me know in advance. Best of luck on the exam. I'll see you all on Wednesday.